Thanks to L2s, users will finally be able to enjoy low fees using their favorite Web3 applications. A much better UX emerges as transaction confirmations are almost instant thanks to Layer 2 sequencers, and help scale blockchains massively. Hello friends, and welcome back to Ethereum Audible, Ethereum in Depth. I'm Yehoshua Zlatogorsky, and this is where we read the best in Ethereum, Web3, and all of that ecosystem. Last week I was a little bit down under the weather with COVID, but today we are going to continue reading The Ultimate Guide to Layer 2s on Ethereum by DCBuilder, a blockchain researcher at Morales. And this is, I think, the most verbose, kind of in-depth, not verbose in a bad way, verbose in a good way, in-depth, that covers so many different L2s out there. This is just a great guide, the ultimate guide to L2s on Ethereum. There's a link in the podcast and the Alpe lesson on the YouTube channel, everywhere that you can get Ethereum Audible. I really recommend you go take a look at it, because while reading through and listening is great, this is really one of those posts that if you want to turn it into something practical and follow up with further resources, the written post really does it more justice. But in any case, we're going to be continuing on where we left off, which is what are validiums, volitions, and then what does this mean for users? But first, just a reminder of what we were talking about last time, which was optimistic rollups and ZK rollups, zero knowledge rollups. Optimistic rollups are where we assume we're optimistic about the system. There is a sequencer that assumes that people are submitting proofs off-chain, and it assumes that those off-chain transactions are valid. There's also someone who watches those transactions to see if they're invalid, and that person, that sequencer, that validator, if they find something that's been going wrong, they can offer a fraud proof, as in a proof that someone committed fraud, and they submit that to the on-chain layer 2 contract. And if someone's found to be doing wrongdoing, then they lose their entire contract, so their entire stake. And that is how you keep optimistic rollups honest. The plus side to optimistic rollups and in general layer 2s is to remove things from the blockchain, the core blockchain layer. And when I say things, just a brief reminder, we have three different layers to a blockchain. We have the consensus layer, we have the data availability layer, and we have the execution layer. The consensus layer is all about reaching consensus on what happened when. The execution layer is where we run the smart contracts. And the data availability layer is where we store data, or at least make it available to anyone who wants to access it. So layer 2s are moving a lot of the execution off of the core Ethereum blockchain, and thereby making things easier to run also on the base layer, but mainly when you run things on the layer 2, they're cheaper and faster. Naturally, that comes with a trade-off of security, and I'll call it consensus, even though it's really decentralization. Security and decentralization often come hand in hand. In a lot of layer 2s, especially optimistic ones, you are trusting someone to submit fraud proofs and watch the chain, and you're also trusting the sequencers to not censor anyone and to not get ahead of you and to be submitting proper proofs. So there's always a trade-off. But anyway, that was optimistic rollups. Next, we spoke about zero knowledge proofs and zero knowledge rollups like ZK Sync, Starkware, Snarkware, Starks, Plonks, Aztec. There are lots of different acronyms, names out there. Zero knowledge proofs are cryptographically much more advanced. And this is kind of next level math. And what happens here is that there is someone who's calculating the cryptographic proof that a transaction has occurred, and then submits that to the main chain. And you don't actually have to have any optimistic proof. You don't have to have someone who's watching for fraud, because the zero knowledge proof, what it means is that that's actually valid. And so even though the transaction is computed off-chain completely, the proof on-chain still holds water. so which is mind-blowing. The downside is that those are computationally hard to do, and so you do it off-chain in a more specialized environment, which also comes with security and decentralization trade-offs. But that was where we left it off last time. And so, without further ado, I would like to dive into where we are now, which is picking up at Volidium and Volitions. But first, I want to thank the sponsors of this show who made this episode possible. This episode is brought to you by Alpe Audio. Want to learn on the go but need more depth than a podcast? Alpe is the app for you. It's an audio education app that brings great in-depth courses that are as fun as podcasts but as educational as a degree. Each lesson comes with summaries, additional resources, flashcards, and more. You can even find Ethereum Audible on Alpe with all of those additional resources. If you want to check it out, head over to get.alpeaudio.com, and that's A-L-P-E, Alpe, A-L-P-E. Let's go, diving right back into DCBuilder's The Ultimate Guide to L2s on Ethereum. We're picking off around midway, a little bit afterwards, with Volidium and Volition off-chain call data. In this section, we'll discuss a hybrid approach to scaling, one that doesn't put call data on-chain and instead takes some compromises in security in order to increase scalability. This approach is no longer considered a true L2, where the definition is a scaling network that inherits the same security guarantees of the network it is built on top of. So what is Volidium? A Volidium is a type of scaling solution that utilizes validity proofs but has off-chain data availability. It compromises Ethereum security. However, it is still much more secure than a sidechain, since the state transitions have verified validity through the use of Starks or Snarks. Currently, Volidium-based solutions only work for specialized use cases and are not universally compatible with execution targets like the EVM, which is the Ethereum Virtual Machine, or WebAssembly. However, with recent progress by teams like Starkware and zk-Sync, this will be possible in the near future. For a more in-depth comparison of zk Rollups and Volidium, read zk-Sync's comparison, and there is a link in the original post. So what is Volition? Volition is an architecture, pioneered by Starkware, that an L2 can adopt where the user can choose whether to use a Volidium or a zk rollup on the L2 on a per-transaction basis. This would allow the user to specify whether he wants to maximize decentralization and security or scalability within the same layer 2. This architecture is getting a lot of traction and is set to be an integral design decision for the Starknet and zk-Sync 2.0 layer 2s, as well as other validity proof-based solutions in the future. Starkware. Starkware has partnered with various projects to build a use case tailored Volidium running the StarkX engine in order to provide massive scalability. For the projects looking for true L2 security guarantees, a Volition model using the StarkX engine is adopted. Immutable X. Immutable X is an NFT layer 2 that utilizes a StarkX Volition infrastructure to provide massive scalability to NFTs. It does this by offering an open NFT marketplace, access for partnered projects to run their NFT games and applications on their network, and a cheap, fast, secure, and scalable user experience to NFT enthusiasts. SoRare is a fantasy football game that utilizes a StarkX Volidium to scale their NFT game for the masses. Diversify is a decentralized cryptocurrency exchange that runs on a custom StarkX Volidium Layer 2. ZK Porter is zk-Sync's Volidium implementation, which will be running side by side with zk-Sync 2.0 in a Volition design. Now, there's more information on all of these in the original post, as well as links to find more docs, and I don't want to run through all of that information because this is a list of different projects and how they connect to Volition and Volidium, just to give you a general sense of everything that's happening. So if you really want to dive more into any specific one, recommend you open the post, click on the links, go read the docs. But let's go back to the post with how can you benefit? Users. Thanks to L2s, users will finally be able to enjoy low fees using their favorite web Web3 applications. A much better UX emerges as transaction confirmations are almost instant thanks to Layer 2 sequencers, and help scale blockchains massively. This will make accessibility to immutable block space much more affordable and help democratize the network for new users through simple and intuitive applications that will abstract all complexities away. Alpha. Many of these L2s, protocols, launching on top, and applications providing services are on the path to progressive decentralization, and part of this process usually involves retroactive token distribution to early adopters and contributors. If you contribute and use these projects now, it's quite likely for you to be eligible for a reward once or if the projects launch tokens. Builders, application developers, protocol designers, and everyone else that partakes in the building process will be able to build scalable, decentralized applications that are mutually composable and interoperable, even across rollups. Scaling does not allow for more users, which brings exponentially more value to a network, Metcalfe's law, but it also allows for more computationally expensive operations to be performed on-chain, which will expand the application design space and make new Web3 use cases economically and technically feasible. Things like social tokens, decentralized social networks, and protocols like Showtime or the Aave social graph protocol and NFT games running on L2s like Immutable X, much more are finally a possibility. Builders are slowly losing the shackles that have slowed them down. ZK rollups have also allowed for custom execution layers that don't need to be constrained by Solidity and the EVM. Current drawbacks. Currently, liquidity is being fragmented across layer 2s, and there are no straightforward ways to use cross L2 AMMs, which are automated market makers, at the time of writing of this article, which is November 14th, 2021. A lot of developer tooling does not work out of the box for DApp development on various L2s, and so tooling teams need to build variations of their software in order to add support for various different scaling solutions. In the future, this will be mitigated with either total EVM compatibility or ideally with EVM equivalence, or a standard design spec which would make it so that ZK and optimistic rollups can share tooling seamlessly. Parts of the technical infrastructure of currently deployed L2s, like the sequencer or the bridge, are centralized, as solutions like Arbitrum and Optimism are in their beta phase, and these guards will be lifted off once they are self-sufficient enough, but that's what it is at today. L2s also break composability and interoperability, and so there's no seamless way for communicating messages across different L2s, nor calling smart contracts from other smart contracts in another layer 2. There's also a lot to be done in terms of Oracle infrastructure and quality data feeds. Chainlink is working on integration with all the L2s, along with other Oracle providers. However, for the infrastructure to be as robust as it is on Ethereum mainnet will take time and effort. Another key issue in terms of the UX for L2s is fiat on-ramps. The vast majority of centralized exchanges currently do not support native withdrawals to L2s, and so it is very cumbersome for someone that is not technically skilled to bridge funds to an L2, especially if they have to pay Ethereum level 1 gas fees. A current workaround is to use an exchange to withdraw to a sidechain like Polygon Proof of Stake, which has sufficient liquidity in cross-chain bridges like Hop or Connext. But the point that we need to work most on is the education of users. I've seen countless people complaining about the high gas fees on Ethereum and migrating to L1s that have a much cheaper transaction fee, like Avalanche, Solana, Phantom, or Terra, at the expense of decentralization and security. As a fellow Ethereum community member, I'd like to ask for help in educating the masses about Ethereum scalability and how they can still be active in our ecosystem in an affordable way. We should also talk to different applications and protocols and submit proposals within their governance forums to create liquidity mining rewards for L2 liquidity and or L2 liquidity bonding. This would make it much more seamless to migrate for users, as liquidity is one of the biggest reasons why users are still using the L1, something which in my opinion won't be the case, as the Ethereum mainnet will be a chain that will act as a data availability layer for L2s, never facing individual users. L2 liquidity. As I mentioned above, there are many valid concerns about fragmented liquidity across the Ethereum ecosystem, as liquidity is not shared across L2s. In this section, I'll cover a few of the projects and liquidity models which are planning to tackle this very issue. HOP protocol. Quote, HOP is a scalable rollup to rollup, which also supports Polygon proof of stake and XDAI, general non-custodial token bridge. It allows users to send tokens from one rollup or sidechain to another almost immediately without having to wait for the network's challenge period. End quote. It works by involving market makers, referred to as bonders, who front the liquidity at the destination chain in exchange for a small fee. This credit is extended by the bonder in the form of H tokens, which are then swapped for their native token counterpart in an AMM, an automated market maker. The end result allows users to seamlessly transfer tokens from one network to the next. The HOP team also provides an SDK that enables developers to integrate HOP functionality into their decentralized applications. Connext. Connext is a network of liquidity pools on different networks, L1s and L2s. Users swap values between these pools, similar to automated market makers' dexes like Uniswap. Connext routers act as the backbone of the network, providing liquidity for user swaps and earning fees in return. They created NXTP, which is a lightweight protocol for generalized X-chain, X-rollup transactions that retain the security properties of the underlying execution environment, and it does not rely on any external validator set. Synapse protocol. Quote from their documentation. Synapse is a cross-chain layer protocol powering frictionless interoperability between blockchains by providing decentralized, permissionless transactions between any L1 sidechain or L2 ecosystem. Synapse powers integral blockchain activities such as asset transfers, swaps, and generalized messaging with cross-chain functionality, and in so doing enables new primitives based off of its cross-chain architecture. The Synapse network is secured by cross-chain multi-party computation validators operating with threshold signature schemes. The network is leaderless and maintains security by each validator running the same process upon receiving on-chain events on the various chains that the multi-party computation validator group tracks. Once 2/3 of all validators have collectively signed the same transaction using their own individual key, the network achieves consensus and issues a transaction to the destination chain. Seller Seabridge. Quote, Seller Seabridge is a multi-chain network that enables instant, low-cost, and any-to-any value transfers within and across different Layer 1 blockchains, such as Ethereum and Polkadot, and different Layer 2 scaling solutions on top, such as Optimistic Rollup, ZK Rollups, and sidechains. End quote. DBridge. Quote, DBridge is a cross-chain interoperability and liquidity transfer protocol that allows truly decentralized transfer of arbitrary data and assets between various blockchains. The cross-chain intercommunication of DBridge smart contracts is powered by the network of independent oracles and validators, which are elected by DBridge governance. The protocol enables transfers of assets between various blockchains via locking and unlocking of the asset on the native chain and issuing or burning the wrapped asset, D asset, on secondary chains or L2s. Cross-chain communication between different blockchains is maintained by elected validators who run the DBridge node to perform validation of cross-chain transactions that pass between smart contracts of the DBridge protocol in different blockchains. End quote. There are a few more here listed in the article, DAMM, Tokamak, but we're not going to read through them because I think you get the point. Summary. Liquidity fragmentation across L2s is a problem that is already being addressed in various ways and by various different players. My personal speculation is that a model that contains a mix of the DAMM, HOP or Connext plus Tokamak designs will emerge in order to abstract Layer 2 liquidity fragmentation away in a form that will make it seem like it's completely unified. We're going to end our reading here, but the post continues with a long list of very useful resources if you are interested in the DeFi world that covers L2 fees, dashboards like Dune Analytics, all kinds of different things. Again, highly recommend you click the link in the resources here and take a look at the original post. But that ends the read here. And I'd like to use the ultimate guide to L2s in the past 2 episodes to wrap up what we've been covering about Ethereum's rollup-centric roadmap. And it has a few components, and I just want to run through them and hopefully this will give you a more structured overview, which will connect all of the different parts that we've been reading about, learning about over the past few weeks. It all starts off with induced demand. There is a problem with blockchains that, unlike a standard network effect company, where the more people you have on a blockchain, or the more people you have on Facebook or WhatsApp, the better the network. In a blockchain, that actually doesn't hold true. It holds true until a certain point, and then there's too much congestion on the network, and you have to get it off, onto other highways. And this is where induced demand comes in. Remember, induced demand is a theory from traffic, from transportation, where the more lanes you build on a highway, the more cars will come drive on that highway because you've made the traffic less. And that is demand that wasn't there in the beginning, but you've induced it by adding a lane. The same is true on blockchains. If you go to alternative blockchains today, and I say alternative to Ethereum specifically, like Solana or Phantom or Terra or Avalanche, they all have much lower fees and much faster transaction times because their highways aren't congested yet. There isn't as much traffic fighting for those lane locations. But that will happen because if their blockchain is useful, that is. But if their blockchain is useful and it brings in users, the network effect will kick in until the anti-network effect kicks in, at which point you've induced too much demand for what you can offer on their main chain. And this is why you need to offload a lot of what happens on a blockchain to other layers. There is no way that I see in the future where a blockchain serves the masses, justifies their huge market caps, and is monolithic. It's one chain that runs and does everything. It just doesn't make any sense to me. It would be like having one highway where all the traffic goes. You have to offload to different modes of transportation, the subway, buses, planes, helicopters, other roads, boats, everything. Those are layer 2s. There's actually a great metaphor for cities around layer 2s, where you might have the main chain, which could be New York, and that's where everyone wants to be who can afford it. But not everyone can afford it. Not everyone wants to live in the main city. So they go live in Albuquerque, and they go live in Philadelphia, and they go live in Europe. And that is what layer 2s solve. They are the other cities, neighborhoods, forms of transportation that offload the induced demand from the network, thereby reducing fees, reducing congestion, so that you can operate on wherever you need. If you're just playing a blockchain game or you own some NFTs, it doesn't have to have the same security. You shouldn't be paying the same fees as someone who's trading billions of dollars worth of assets value. It just doesn't make any sense. And that is why we need layer 2s. And just to remind you, a blockchain has 3 purposes. It has the consensus layer, it has the execution layer, and then there's the data availability layer. And each one of those should be separate so that you can scale them all up. Layer 2s today mainly serve the execution layer, but you could also have layer 2s serving data availability. That's kind of what shards are. Scaling the execution is the promise of layer 2s today, whether it's optimistic rollups or zero knowledge proofs. That is what they're coming to solve. And I think the promise is already, when I'm recording this in early 2022, I can already see it playing out. I do a lot of my activity on layer 2s, whether it's Polygon, which debate proof of stake sidechain, or layer 2, on Arbitrum, on Optimism. Things are already happening there. I highly recommend you go check them out and you start migrating off of the main chain, because gas costs are a fraction. And for most of the things that we do, we don't need the immediate finality or close to immediate finality that the main chain gives us. And that's the promise, and the activity is already going on today. DCBuilder went into a great section towards the end on liquidity, which is spot on, but that's also slowly being solved. And the more people that migrate, well, the more liquidity there is. And if you believe, like I do, that a very large chunk of the world's economic transfer will shift over to blockchains, then liquidity is a problem that will be solved just by nature of that economic activity shifting over to blockchains. And so it's a long-term game, but we're going there. The other thing that excites me about layer 2s is what we haven't been able to do today, but will be able to do in the future. And that comes into play in my mind in two fronts. One is really with lower gas fees, you can just do all kinds of different applications that you can't do on the main chain. And that's number one, and that's already happening, like gaming and different kinds of NFTs. The other one is because of the cost of gas, there are computations that you can't do. It's just not economically viable, but you can do these on layer 2s. You can do these with zero knowledge proofs. And part of what's exciting about the work that DYDX and Starkware are already doing today is that these are computations that don't work on the main chain. There's a reason that AMMs, automated market makers, are the norm on Ethereum layer 1. This is Uniswap. If you've ever traded on Uniswap, this is what it is, and not something more sophisticated. And the reason is because this is a much lower cost in terms of gas and computation way of market making. But there are all kinds of more complex computations you could do off-chain with different kinds of layer 2 solutions. So there's literally things that we don't know will happen on the blockchain that will be built because of layer 2s. Now, naturally, none of these things come without a trade-off. And this is really important to say and stress. Layer 2s come with security risks that don't exist as much on the layer 1. Mainly decentralization, but also just general bugginess and holes in the code. The more variables you add to a system, the more fragile it becomes. Bridging assets between layer 2s and layer 1s, bridging assets between layer 2s and layer 2s, all of that adds fragility to the system. Those are kinks that have to be worked out, that will only be worked out over time as we find those bugs. Some of them will be discovered in hacks. Some of them will be drained of their funds. Just last week, there was a massive $300 million bug that was found in a protocol called Wormhole, which bridged assets from Ethereum to Solana. And those things are bound to happen. And that's another trade-off that you just have to be aware of. And when you manage where you migrate to, take that into account in your risk management. Don't put all of your eggs in one basket unless it's a really, really tried and true protocol that I think the entire ecosystem can trust. But those are trade-offs that are just part of the future of blockchain and part of the future of Ethereum. So we've finished a bunch of read-throughs on Rollups and the Ethereum roadmap that puts Rollups at its center. And I really, really hope that by now you have a good grounding in the different kinds of rollups, why rollups are important, the trade-offs that we have when we use them, and why the future of Ethereum is so rollup centric.